Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to be looking at how to find a tangent line to an equation at a particular point. So let's go ahead and get started. Now, this is kind of complicated, and so again, it's always better to go through an example than to try to deal with all the details. So this is what we're trying to do. Now, a tangent line is something that touches another equation line at one particular point, and it only touches it at that one point, and that's it. That's kind of how it works. So if I have a line like this, my tangent line would be something. If the point is right here, my tangent line might be something like that. Again, my handwriting is not the most beautiful, but you get the point. It only touches this white line equation at one point, whatever it is. And so we're going to be trying to figure that out. So what's going to happen is that we're going to have an equation, some sort of an equation, and there's going to be a particular point, because remember, we're basically finding the derivative. So we're going to be looking at a particular point and trying to figure out what is the tangent line equation at this particular point when you are considering this other equation that's happening at the same time. So the equation that we're going to be using is basically f of a equals 5x squared minus x plus 4. And so what we need to do is as follows. First of all, one more thing, and that's where x equals 2. We need to find out, okay, what is the derivative? What is the instantaneous change at this particular point? And then once we know that, we can build the equation around it when x equals 2. And so what we want to do is simply that first we find the derivative, and then we need to try to find our basic slope-intercept equation based on that point. And I know this sounds weird right now, so let's just do it step by step first, because this is really hard to try to understand piece by piece. Now, what we're going to do is, first of all, we're going to find the derivative for this guy right here. And to save a lot of time, because doing it with the limit takes a lot of work, we're going to use the power rule and just wrap this up quick. I will do a video on that later, but for now, just kind of trust me in terms of what I do, because the old way is just takes forever. So basically what I'm going to do here is I'm going to take this exponent here up here, and I'm going to bring it down here. And I'm going to subtract 1 to this, so I end up with the following. 2 times 5 is 10. 10x, 2 minus 1 is 1, like so. That's what I do here. Now for this one, there's basically a 1 up here, so I bring that down to the front, and this becomes a 0. And so whenever you have something raised to the 0 power, it becomes a 1. So minus 1, and then for this guy, he disappears, because again, he's raised to the first power. You bring him down here, is 1 times 4, when he's at that, and it becomes plus 0. That's kind of what happens. Again, I will explain this more in the future, but for right now, we can say for sure that the derivative of this equation is going to be 10x to the 2x minus 1. Now, what we do next is that we plug in our 2, because this is our point that we're going to be using. We're plugging this in. We're going to plug this in wherever we have an x at. So if we wanted to try to make this as clear as possible, it's going to be f, the derivative of f at 2 equals 10 times 2 minus 1. And so what we get is that we get f, the derivative of f at 2 equals basically 19. So in other words, this is the point on the graph where our tangent line is going to be based at. In other words, our tangent line is going to touch this original equation right here at the point 2, 19. That is what that's what we have right here. The 2 comes from the fact that I plugged that in right here, and the 19 is what I get out. So 219. That's what we're going to be getting. Now, here is the next trick that we're going to be doing. Next, we're going to be trying to find the equation of the tangent line. So I'll just do that on a new screen. Here we go. So this is what it looks like. This is the formula. So we have f2, and it's going to be time. F at 2, this is the slope, if you will. That's the point at which it happens. The slope, the point where it touches. So then we're going to have x minus 2, because this 2 right here is our a value, our original a value, and then plus f of 2. All right. So we plug all this in. Now this f of 2 right here is based off the original equation. That's what it's based off of. So let me just show you what's happening here. Let me just change colors real quick. So this f of 2 right here is going to come down and be a 19. 19. And then we're going to have x minus 2. And then we're going to have plus. Now for this one right here, we have to take our original equation, which in case you forgot was this 5x squared minus x plus 4. That's what we got to use here. And so to make this as simple as possible, so we're going to do 5, then 2 squared. Whoa, whoops, I don't want the negative there. Minus 2 and plus 4. So 2 squared is 4. 4 times 2 is 20. Minus 2 plus 4. 20 minus 2 is 18. Plus 4, that's going to give me 22. So this guy right here is going to come down and be 22, like so. So right now our equation is 19x minus 2 plus 22. So we're going to distribute the 19 here. We're going to have 19x minus 38 plus 22. Simplify. We're going to have 19x minus 16. So this is our slope-intercept form, if you will. And so this is the equation of the tangent line for when you have the original equation 5x squared minus x plus 4. And so if you're set at x to 2, this is the equation of the actual tangent line when it touches at that one point, and that is at 19. So here we have a picture of what I'm talking about. To your left, the furthest one to the left, this is our basic equation 5x squared. I'll just write it next to it. 5x squared, let's see here. 5x squared minus x plus 4. That is this guy right here. And so you can see, you guys know that the number in front, it affects how wide the parabola is. The next guy right here, it moves it to the left or to the right. And then the plus 4 moves it up 4 units. So you can see that right there. And so this is where it's at. And you can see our point 19 right here, 219, like so. That is where it touches the line, and that's the only place that our next equation is going to touch it. And then if you look at the next equation right next to it to the right, this is our 19x minus 16. And so you can see it goes up and it touches right here, and then it doesn't really touch at all ever again. And so that is the tangent line for the original equation 5x squared minus x plus 4. Again, a lot of complicated, okay, it's not complicated. It's just you have to know what tool to use and in what order to use it. Because all you're basically doing is in all these problems is add, subtract, multiply, divide. That's all you do pretty much in all the mathematics. The question is, when do you do these different things and at what particular moment? And that's where it gets very, very confusing for people when they're trying to deal with mathematics. So let's see if we can kind of go back and review this and wrap up the video. So in this video, we looked at how to find the tangent line to an equation at a point. So you pick a point. So for us, it was going to be x equal 2. And you want to see what is the tangent line at that particular moment. So the first thing that you need to do is you find the derivative for the original equation. And we did that. And then you plug in your x value where you want to find the tangent line. And that's what we did. And our ultimate goal, as I mentioned before, is to find a basic slope-intercept equation that has x equal 2 in it. That's what we're trying to do. So this is what we're doing here. And so on the next screen, what we did here was once we got our value 19, our next goal was to put in this 19 because that is our slope, if you will, and to try to find our slope-intercept equation. And so we put in our 19 for f prime 2, and we had our x minus 2. This 2 comes from, this is where we want to find the actual line at. That was our original value there. And then the f of 2, this is when you plug in 2 to the original equation. For us, that was 5x squared minus x plus 4. And so when you do that, you get all these numbers. You get the 19 here, x minus 2. Remember, this 2 was our original point that we wanted to find out where the tangent line was at. And then we have plus 22. That is the result of putting in 2 to the original equation. And so when you do all that and you distribute the 19, you get 19x minus 6. Once you do all that, here off to the left is the original equation, and here off to the right is the original equation, plus it has the slope-intercept, or excuse me, the tangent line of the equation that we found. So I hope this video, Hope this video was useful for you and you were able to understand what we talked about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.